matplotlib, and then you use plt.plot. You plot your data. So what matplotlib does is, instead of asking you to input both an x-axis data set and a y-axis data set, you don't have to put in an x value data set, because matplotlib is gonna do that for you.
Oh, automatically. Okay.
Yeah, it's gonna increment by 1.
All
So
right.
if
But
that's what,
you can define it to increment differently if you wanted
yeah.
to, right? Yeah, okay.
Yeah. Okay, and then we're just gonna label the graph with the x-axis being the epochs, and then the y-axis as cost. So it's a cost
Okay.
versus epochs graph.
Yeah, yeah.
And then we can save the graph using fig.savefigure. And then this is the file name we're gonna save it to, and then we close out the figure by calling plt.close. Okay.
Okay.
Then what we get is this. See, it starts off here and now it's like really close to 0.
Uh-huh.
Okay, so our model has technically learned at this point. We
Yeah.
have 10, we have 10 for the weights and about 20 for the biases, and that's what we want, right?
Mm-hmm.
And then our cost is really low right now, 0.0009. So
Yeah.
like 0.001. Okay.
9.8 times e to the negative. What is it, 4? Yep.
Okay. And then so it seems like our optimizer, SGD. So SGD means stochastic gradient descent. So S, G, and then D.
Oh, okay.
Stochastic
That's
gradient
where
descent.
that's where the function name came from. Okay.
Yeah. So it seems like doing this is good. Like the model has learned with SGD, but actually there are a lot more optimizers that we can use that is better than SGD. So one of the
Okay.
problems with SGD is that it takes way too long. See, it takes like 1,000 iterations, 1,000 epochs, right?
Uh-huh.
And then that's pretty long. That's like a lot of epochs. So what we can do is, to see why it's going so slow, we need to go to a deeper level. So what is changing the cost? So what are we doing to change the cost?
Um, oh, oh. Sorry. To change the cost, you're basically taking the partial derivative and multiplying by
Yeah, so
learning
what we're
rate. Yeah.
doing is we're
Or negative
changing the
partial derivative.
parameters.
Yeah.
Yeah. So we're
Okay.
changing the parameters. So what we can
Yeah.
do at the same time while we're doing a cost function graph, I mean a cost graph, while we are updating parameters, we could also do a parameter graph as we're updating the parameters. So over here, here's the cost history list. We started off as an empty list to be a placeholder, and for the weight history and the bias history as we're updating. And then while we're updating over here, we're gonna append the weight and then the bias and also the cost.
Mhm.
Okay. Yes.
Wait, history for what again?
History as we're updating. So history for the
Hold on,
weights
hold on,
and the
hold on.
bias and the cost.
Oh, you just have. Oh, I thought those were. I was wondering where those came from. Never mind.
Okay. And yeah. So after we update them, we can graph them. But then so graphing them, we would have to like have this function done, like we would have to copy and paste this like 3 times, and that means we have to put it in a function. So what we do is we start with a graphing space in this function. We plot the data, which is our first argument, into the function. And then we label the graph using our, we have an argument for the X label and then the Y label. And
Uh-huh.
then we have an argument for where we want to save the file to.
Okay.
Okay, and then so what we get is you see the weight, it starts off like it increases way too much, and then it slowly comes back to 10. Okay.
Yeah.
And then for the bias though, like we're increasing. So like if we're increasing slower and slower towards the end, right?
Yeah.
So what we need to do is we need to get the bias to increase faster. Like this is too slow.
Yeah.
Okay.
Okay.
And now
And
the
yeah,
weight.
I think that's where we ended off last time because we ran out of time. But yeah, continue.
Okay. So and then over here we're gonna. So what we need to do is slow down the weight updates because this increase is way too much, right? Okay. So the reason why it starts to slow down. So for if you look at the bias, the reason why it starts to slow down as training gets longer and longer is because if you like look at a cost function, right? So over here, your slope over here is the biggest, right?
Uh-huh.
But then as you get closer, so let's say zero is what what you want the prediction to be equal to, okay?
Yeah.
So if zero is the prediction what you want it to be equal to, as you get closer to zero, your derivative, your partial derivative is getting smaller and smaller.
Yes.
Okay,
Makes
so
sense.
as it goes smaller and smaller, if you remember the equation, it was like, let me find it. So it was this. So it was so this is how we update things, right?
Yes.
So if the gradient gets smaller and smaller, then I mean, if the partial derivative gets smaller and smaller, our update is gonna get smaller and smaller, right?
Yeah.
So that's what's happening over here. So that's what's making the bias slow down its learning as time passes.
Oh, okay.
Yeah. Okay, and then so what we need to do is first we want the parameters to update faster, okay? Want the parameters to update faster. And
Mhm.
then you want the bias to increase faster, and then you want the weight to uh to slow down its learning. Okay.
Okay.
So yeah, so that's what we're gonna do next, which is other types of optimizers. But then before we get there, I need to talk about the two different cost functions. So you remember MSE and MAE?
Yeah.
So mean squared error takes the squared error, but takes the average squared error between each example, I mean each prediction. But
Uh-huh.
then mean absolute error takes the absolute value of each error on takes the takes the average of every absolute value error.
Uh-huh.
Right? So if you take a look the two different graphs. So let's say, so you know how what we have for, so it's the correct value minus the y prediction, right? And then we square that, right?
Yeah.
So let's just say that x, okay, let's just say that x
It's
is
equal to
going
all of that.
is going to be the difference between so it's just gonna be y minus y hat. Yeah, y minus y hat, okay?
Okay.
Actually, y hat minus y. I did it in the wrong order.
Your what is it? I mean,
Okay.
even in stats, yeah, that's your what is it? Predicted minus actual.
Yes.
Okay.
So, and then for the MAE, we have the absolute value, right?
Mm-hmm.
So what happens is that as your difference increases for MAE, like you still increase by the same amount, right?
Yeah.
But then if you take a look over here for MSE, as you get farther and farther away, your cost exponentiates, right?
Yes, I see.
So the farther away you are, let's say you're over here on the cost function, right? So if you were
Mhm.
over here, you're gonna learn really fast because your partial derivative at this point is really high, right?
Yeah.
So you're gonna go down. So you're gonna learn faster in the beginning stages, right?
Yeah.
So that's what we want. But then for MAE, I mean, yeah, for MAE, the slope is always 1 or -1.
Uh-huh.
So it doesn't matter so it's not really how far. So it doesn't really penalize the model for having predictions like way off.
Uh,
So
that's not
what
what we want, right?
yeah, MAE though, it's good at outliers because outliers you might have some data points that are like all the way over here, right?
Okay.
But then for MAE, I mean MSE, mean squared error, if you have like points really far away, like their cost is gonna be really high. And then the model is gonna try to also, the model is also going to try to predict right for the outlier. And
Yeah.
you don't want that. So MAE is more robust to outliers, but MSE is not as robust, but it helps the model learn faster on data sets that don't have a lot of outliers.
Yeah. All right.
Okay, so that's why that's why I'm always using MSE because our data set, if you take a look at our data set, does it have any outliers?
No.
Yeah, so that's why I'm using MSE. So the first one,
Okay, okay.
the
Yeah.
first optimizer to replace some SGD is momentum. So momentum has a lot to do with physics. So like people made momentum by learning about physics. Okay, so let me erase this, clear on
Are you taking AP Physics this year?
what?
Are you taking AP Physics this year?
Yeah.
Have you
So,
gone through the you can't run from momentum whole thing?
bro, we haven't even started learning about momentum.
What?
Yeah, like Carter's really behind this year.
Oh, why?
I don't know. He spent like we spent like 4 months on kinematics.
Jeez.
Like kinematics is so freaking easy. He spent like years on that. Okay,
Yeah.
so let's just say you have a ball. So let's just say this is a hill, okay?